Hey everybody, this is Larry. This is day 2 of the Leetcode Daily Challenge for November. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, which is insertion sort list. So apparently, this has been out for a little bit because of daylight savings. It's always very confusing. But anyway, let's look at today's problem. Let me know what you think. Insertion sort, it repeats now, okay. Okay, so insertion sort for a linked list. I guess it is what it sounds like. Do we return the head? Is that what's going on? It's not very clear. Okay, so you return the head, it seems like, because it's not clear from this example that what it is. But I think it is just literally implement the insertion sort. So it should be pretty straightforward. If you know the algorithm, which they tell you. So let me know what you think. But yeah. But so I'm just trying to think whether it makes sense to get the smallest element first and then put in the front, or get the biggest element, put in the front, and then just keep on doing it that way. That's what I'm thinking about. I think obviously it makes no difference realistically, but I guess depending on how you want to upsolve and how you want to be precise, we can do this. So let's just keep track of a tail, which initially we're going to put let's just say none, right? And this is where we insert our biggest element. Right? Oh, sorry, our smallest element. And then now we just need a loop. While true, I just say current is equal to head, maybe. Now first, find the smallest element starting from some head element. From current, maybe. We'll have to figure this out. We'll have to clear this out as we code it, but yeah. So first we start, and let's just say new head is equal to none, maybe. We'll figure it out. And actually, that we should we just say the tail should equal to head, right? And all these things don't technically matter, to be honest, as long as you make sure your invariant for the problem is correct. Then as long as you kind of code the rest of your problem with the same invariant that you came up with, that should be okay. So let's just say current is equal to tail. Min element is equal to, let's say, infinity for now. Min element value, say. Min element is equal to current. I guess we don't need the element value then in that case. While current is not none, current is equal to current.next, but not before we check to see if it's the min element. So if min element dot value is greater than current dot value, then min element is equal to current, right? So this should get us where we need to be for the tail. And now tail is where you begin. Maybe this should be tail. This is a little bit weird. I think that's why. Okay, let's just say I think in theory you're supposed to move this forward, but I think we could actually just create a new list. So let's do that. Let's just create a new list. Then this makes it easier, and then we just go to head, right? We could go through the head every time, and yeah, and then now min element should have the smallest element. So then new head, so none, new tail is equal to none. And you could do it another way with the sand nose, but that's the way I'm going to do it. So yeah. So new head we don't really care about, but new tail, in theory, we add next is equal to min element, right? This is just really annoying to get right, because then now you have to delete min element, but then you have to kind of make sure that the previous pointer to min element skips you, so it's like all really weird. That's why I always find these problems annoying, but it's okay. We could find it. I mean, we could just do another iteration, but it is not a fun problem. It's not hard. It's just annoying and bookkeeping, as I would like to call it. Let's just have a previous. And a min element previous. This is ridiculous, but okay, fine. This is so much easier with a doubly linked list, but maybe that's fine. Okay. Right, something like that. Okay, and then now we can remove the node. So previous. Also, if previous is not none, then we. Oh, okay, maybe the other way. If previous is none, that means that we're removing the head. So head is equal to head.next, and that's all you need really. Yeah. Else, then previous.next is equal to min element.next, and that's pretty much it as well. And now we want to put min element in the next best, so we do this, but we not before we go if new tail is not none, then we just do this, and that's pretty much all you have to do. If new tail is none, then that means that new head is none as well. Then new head is equal to new tail is equal to min element. I think this should be good. Let's return. Yeah, I think the while true is that we have to make sure that there's still an element. So while head is not none. Yeah. Let's give it a go first and then see if that looks okay. Not that confident, to be honest, because these things are always tricky. And I have to, yeah, and that means that there's an infinite loop somewhere. Also, I just want to put in this case as well, though they don't make it cut and paste friendly, but that's okay. So time limit exceeded. That means that, well, head, we don't set head, that's why. In theory, this should trigger eventually when head is the min, and then this should be none. But I think, there may be some invariant that's not true here, so we remove current. Oh no, we remove min element. Oh, this is actually min element previous. I got them confused. So maybe that's why. Let's hope so. Well, okay. It's something. It's not the right thing, but it's something. Oh yeah, we set new tail.next is equal to min element, but then we set new tail is equal to new tail.next, because now the new tail is the new tail, right? Easy mistake to make. Okay, so let's give it a submit. Actually, usually I test like one element cases and stuff like that, but forgot this time. So yeah, but it looks like it's okay. It's about 30 lines of code, but to be honest, it's still a little bit annoying, a little bit just bookkeeping. And it's the tricky part is that there are a lot of edge cases, and with experience and practice, you can kind of see where the edge cases are and then code it in a way that makes it easier to handle the edge cases. Otherwise, it's just gonna be a lot of if statements. I'm not saying what I have here is the best, but looking at it now, to be honest, I'm pretty happy with what I have with respect to like keeping it small and tight. Linked list is a thing that I honestly myself don't practice as much because it doesn't come up that much in competitive programming, right? So yeah, let me know what you think about today's problem. Let me know if you have issues. It's okay. Like I think algorithmically it's not that interesting per se, but there are a lot of possibilities for implementation issues and off by ones and weird pointers not pointing the right way. So it's good practice for implementation purposes. Anyway, that's all I have for today. I will see y'all next problem. Bye-bye.